the Druid approach is to kind of think about this a little bit differently. The Druid approach is, rather than pushing all the analytics into the stream processor and having a dumb storage system that's just coughing them up and having to model that data in ways that are very tied to the application that you're building. The Druid way of doing things is to put the actual data, raw data, or maybe lightly processed or somewhat moderately pre-processed or pre-aggregated into Druid, and then have an application to sit on top of that. And Druid speaks SQL. So you can put traditional business intelligence applications on top of Druid, like Tableau and like Looker and Superset and things like that. You can build your own application using SQL, which is nice because it's a commonly known language, very flexible as well. And also that Imply Pivot app that I showed you earlier runs on top of Druid. So the idea is that rather than embed a lot of logic about the exact way your dashboard looks, rather than having to build a key value schema based on the app you want to make, you load your data into Druid and then you can build apps on it. They're a bit more decoupled. The development cost is lower and the system is more flexible. So in order to make this possible, you still want a way to enrich data. You still need a way to do stream joins. You still need a way to attach that GeoIP data. It's still best to do that before the data goes into the analytical database, Druid, just for performance reasons. So it's still best to do that with something like a stream processor. So it's not like they don't have a place. They do have a strong place in this world, and that place is enriching data, preparing data to be loaded into a database. You do then a continuous load of data from Kafka into Druid, and in Druid the aggregation and serving layers are merged. Instead of having a separate system where, on the previous slide, instead of separating the aggregation layer into a stream processor and the serving layer into a state store or key value store, in the Druid world, this aggregation and serving layers are put together. And that's what gives you the power and flexibility. So the core idea is use a analytical database that has this kind of power. Internally, actually, interestingly enough, the Druid architecture actually looks a little bit like that classic real-time analytics architecture where things are separated. But internally, it looks like that, but it hides a lot of that complexity from you. And it hides it in a way that allows it to become more powerful as well. So that internally what Druid's doing is you're loading files, you're loading streams. They go into something called an indexer. So Druid's got a process called an indexer. Druid's got a process called historical processes. So the indexer handles real-time data or data that's been written generally over the last hour or so. The historical processes handle older data. There's a handoff process where data is compressed, optimized, indexed. That's why it's called the indexer. Handed off to historicals. So in most clusters, in most Druid clusters, 95% of your data is going to be on the historicals, and then a little bit is going to be on the indexers, the real-time data. And queries will hit both. So this concept of being able to hit both, permanent long-term storage, which in the classic architecture is a key value store, and hitting direct state that hasn't been put into permanent storage yet, which in the classic architecture is the state store of your stream processor. In Druid, that's the indexer and the historical, but it's all handled by Druid itself. Users, you developers, just hit one Druid server called the query broker. You issue SQL queries to it, and then it will figure out, okay, I need to get this bit of data from the indexer, this bit of data from historicals. It'll stitch it all together, and you don't have to worry about it. So that's the mechanism by which it reduces the amount of dev effort you need to put in to get your apps built.